Hopefully my voice won't give out. I'm trying to fight a little bit of a cold. So as was mentioned, my name is Gordan Mansfield, and I have responsibility for the radio network development at AT&T. And so everything from the antenna down to the OEM equipment, the selection process that's done via my team, driving our vendors to capabilities that we need to deliver ultimately. So I'm going to start by telling you that customers, they don't really understand issues like spectrum management, network architecture, capacity, or latency. What customers understand is that they want information on the go and they want it fast. So basically the sea change of customer behavior has come about because of the convergence of high-speed networks, a new generation of consumer-friendly devices, and the explosive growth of applications which have brought about incredible functionality. In meeting the demands and growing expectations of the new consumer behavior is a continuous challenge that we operators have to work on constantly. We at AT&T plow billions of dollars annually into our network infrastructure, installing new antennas, deploying enhanced backhaul capabilities, and improving various network elements. I'm going to take a few minutes today to outline AT&T's plans to continue to meet these growing demands through the enhancement of our HSPA network and through the deployment of LTE, while also continuing to leverage our Wi-Fi networks. The central message today is the time is right for LTE with its faster speeds, lower latency, and greater efficiency in handling data. But as we roll out this high-speed network, it's also crucial that we provide the best overall customer experience across the current and new networks. Because until the LTE deployment is universal, a high-performance HSPA network is the best way to keep customers from experiencing what we like to call wireless whiplash when their LTE device finds themselves in non-LTE territories. That's why AT&T is continuing to upgrade our existing HSPA network with faster speeds. So as many of you know, the story behind HSPA at AT&T has been one of continuous improvement. We launched the first widely available HSDPA network in the world in 2005, giving AT&T the early jump on 3G in the United States. These faster download speeds brought immediate new capabilities for laptop users, and then of course it opened the door for the explosion in smartphone and tablet innovation that we're now seeing. But we really didn't stop there. We upgraded the network 2 years later to include HSUPA capabilities, which meant faster uplink speeds. It also meant that we could drop a letter from the acronym and simply call the technology HSPA. Last year, we upgraded our network to HSPA 7.2, which allows the theoretical peak downloads of up to 7.2 megabits per second, which is theoretically twice as fast as the 3G technologies available from our CDMA competitors. But we've also been busy upgrading our backhaul deployments in order to get the most speed out of our networks. As I'm sure that most of you have seen, we've not stood still, and we're still continuing to upgrade our mobile broadband network. We really don't intend to stop anytime soon. Earlier this year, during CES, we announced that we've deployed our HSPA Plus software to nearly 100% of our network. We've also announced that we've accelerated our LTE deployment and plan to be largely complete by the end of 2013. When you consider these two together, we believe we are building the nation's most advanced mobile broadband experience. So with the 3GP family of technologies, we have the best overall suite of mobile broadband services for our customer base, both today and into the future. Our HSPA Plus network, when combined with enhanced backhaul, should allow users to achieve approximately 6 megabits per second, which really does provide 4G speeds today, while LTE will bring even faster speeds in the future. We believe that our timing and our network strategy is well matched to the widespread availability of devices. We have our LTE trials going on today in Baltimore and Dallas, with the launch of LTE expected later this year. We plan to have 70 to 75 million POPs covered by the end of this year. So with HSPA Plus and LTE, our bench strength is unparalleled. Put another way, having LTE with HSPA Plus as a backup is like having Tom Brady as your starting quarterback with Peyton Manning on the bench. Sorry, with the Super Bowl, I couldn't resist. So with these new faster mobile data networks, we are fulfilling the promise of the mobile internet. The broadband on your handset, your tablet, and your laptop. The ability to connect new devices, from automating your home to connecting your car. The ability to wirelessly enable a host of vertical devices and applications for enterprise customers. We as an industry, we want and we need to keep businesses and consumers excited about the advances we're making in broadband services. But again, keeping the customer excited means doing it right. And that means providing the best overall experience with mobile broadband from the network to the devices available. So speaking of device availability, as some of you I'm sure have seen, we've announced 20 4G devices this year, with a couple of new smartphones coming out this quarter. I don't know about you, but when you take all of that together, it makes for a pretty exciting time. So far, I've outlined the basics around AT&T's network evolution to LTE and the reasoning behind it. I would like to switch gears a little now and tell you why LTE is the right technology going forward. I'm going to do this in the context of what's been driving much of the internet traffic, both wireline and wireless, in the last couple years. I'm talking about, of course, social networks. Social networks have taken an unwieldy internet and created a passion point for users. Whether you're following your friends, your sports team, your favorite vacation destination, or even your favorite product, social networks give users the opportunity to tune into their individual interest. Tapping into that passion means, of course, that they are also consuming bandwidth. Two numbers from Nielsen research stick out. First, the average Facebook user spends 7 hours a month on the social networking site. The second part of that is that the mobile internet users spend more than 10% of their time on social networks, second only to email. So a lot of people don't realize this, and frankly neither did I until somebody pointed it out. But the history of the 3G networks and the history of social networks are really on close parallel tracks. If we look at this chart, MySpace was founded in 2002. Facebook was founded in 2004, and YouTube was founded in 2005. The first commercial network was launched by NTT Docomo in 2001, the first 3G network. AT&T launched the first widespread HSPA network in 2005, and the first commercial EVDO network was built in around 2006. And so the growth of the two industries actually is pretty amazingly similar. Facebook went from serving the 21,000 students at Harvard to a global community of more than 500 million users in just 6 years. The most active Facebook members, not surprisingly, are the ones who value mobility. According to Facebook's own statistics, 150 million active users connect to Facebook through their mobile devices. And people who use their mobile device to connect to Facebook are twice as active as their fixed-line counterparts. So if we compare this to the type of growth that we've seen at AT&T. So on this chart, you may have seen this before, but it bears repeating. At AT&T, we have seen a 30x growth in data usage in just 3 years. That growth has moved hand in hand with more consumers moving to smartphones and other data-centric devices like tablets. Social networks really have been the leader in adapting to platforms to smartphones, and in turn, changing consumer behavior on mobile networks in ways that no one really could have predicted. The biggest change has been in the use of video. For any of the naysayers out there who question whether consumers would ever watch video on a 4.3-inch screen after buying the big 50-inch widescreen at home, I'd like you to check out these numbers. So Allot Communications, which monitors traffic trends for ISPs, said recently that 1/3 of mobile traffic today is video, and that YouTube makes up 13% of all mobile data traffic. So if we speak of the popularity of YouTube, the mobile web solutions provider Byte Mobile said in its third quarter Mobile Minute Metrics report that user-generated content originating via websites like YouTube and Google Videos already account for 48% of worldwide mobile video traffic. If we add to that the streaming video services from companies like CNN and ESPN, you have some serious growth in the amount of data that's coming down the pipes. And so where is this going in the future? According to most predictions, it's no place but up. Coda Research Consultancy is predicting an annual compound growth of 138% in mobile video by 2015. Coda expects video will consist of 224,000 terabytes of data per month in the next 5 years. So why is all of this important when we look at LTE? Because not only can LTE provide the type of speed that we're looking for to download video, it handles the data much more efficiently. LTE will bring higher throughputs, a marked improvement in spectral efficiency, and much more latency than what's really available today. But guess what? That video is not a one-way street. While most of the traffic today is coming from the downlink, more and more users are creating content and uploading it to the internet via their mobile phones. In fact, Facebook says that their members are uploading 20 million videos each month, many of which are being shared from their mobile devices. That really is fantastic. But what it means is that operators have to provide faster uplinks for their customers to meet expectations. As I've mentioned earlier, we have upgraded our networks to HSPA several years back to increase those uplink speeds. LTE is our next logical step. LTE provides an additional improvement on uplink throughput and about a fourfold improvement on uplink spectral efficiency. Network upgrades are key components of being able to handle the growth of video. But of course, they're not the only component. Writing efficient video codecs is key to providing a great customer experience. In studying the video that goes over the network, we know that some video content takes 6 times the amount of data to stream as the most efficient codecs, without really a visible difference in quality. So producers of mobile video must continue to seek out and deploy the most efficient systems so that we can meet customer expectations and the demand as we go forward. This is especially important as video becomes commonplace among enterprise users. We anticipate that a growing number of vertical industries will use video extensively, including medical, monitoring, and security. We don't want to leave out our news providers, who we know are looking for alternatives to high-priced satellite and microwave trucks to get on the scene as rapidly as possible and shoot that all-important video feed. So this leads me to another key reason why LTE is the technology at the right time. We are moving to a world in which more and more devices are connected to the internet, and we need the right technologies to make these connections. So I deal a lot with software development, but I also deal with hardware development. And so, I'd like to say that simply evolving the technologies from HSPA to HSPA plus to LTE is all that it's going to take. But that's really not the case. It's also going to take the evolving, in addition to the evolving of the technology, we have to look at how we construct our network to serve our customers where they are with the right technology. A lot of people ask me, why is this important? The simple truth is that greater than 80% of wireless traffic growth in high-density areas is in building. To serve these areas well, we need smaller, cost-effective solutions to provide the best possible signal with the right access technology so that the users can achieve the full promise of mobile broadband everywhere they are. This is why AT&T has a major focus on continuing to develop small cell technologies like the 3G microcell that we introduced last year, so that we can expand the options available for use in these areas. We are looking at HetNet and other greater capacity solutions, utilizing technology similar to that in femtocell networks today. We are already utilizing distributed antenna base station technology, which allows us the flexibility in how we deploy what many would consider traditional base stations. This gives us the flexibility on how we deploy sites in areas that are difficult to get signal where the users are. In addition to looking at new base station technology in different base station configurations, we also have approximately 4,300 distributed antenna systems deployed in commercial buildings and environments today. We will continue to evaluate locations to add these systems with a big focus on venue locations like stadiums or in downtown areas like here. This is downtown Chicago, where we have a lot of capacity. It's needed across multiple access technologies in very centralized areas that are difficult to build traditional sites. So not only is AT&T evolving our mobile broadband technologies and evaluating new ways to deliver these technologies to serve customers in dense areas, but we're also creating solutions to enable our customers to leverage our Wi-Fi hotspot networks that are already in place today. At AT&T, we have more than 23,000 hotspots today, and we've recently added the Wi-Fi hot zones in New York City, which we just recently expanded, Charlotte, Chicago, and just recently added San Francisco to that list. So if we think about and speak about Wi-Fi, at AT&T we have seen actually the growth in Wi-Fi connections grow at a pretty spectacular pace. This chart shows that we've had actually more Wi-Fi connections in the third quarter of 2010 than we had in all of 2009. We are projecting a 5x growth in connections this year. So we really don't see Wi-Fi as a competing technology. We see it as a complementary technology and a complementary solution to our mobile broadband network. That when we couple this together with LTE and our HSPA Plus networks, it gives our customers the ability to use the right network at the right time with the for the applications and services that they desire. So to close it out, what I'd like to really do is focus on a couple of the things that we believe are the sustainable model to meet our customers' demands. With the introduction of LTE networks, we will take advantage of new spectrum that we've acquired in the lower 700 and AWS bands, which will give us an increase in the available spectrum to use over the 850 and PCS spectrum that we have in our HSPA networks today. I'd be remiss if I said that was still enough. We as an industry are going to have to continue to look for new spectrum to be designated for mobile broadband use, while the growth will continue for years to come. With HSPA Plus, we will bring 4G speeds today, and LTE will bring additional speed, lower latency, and spectral efficiency as it is deployed beginning later this year. We're also working with our applications developers and partners to ensure that the applications that they're building to utilize network resources are done so in a much more efficient manner. It's very important to partner in that area and make sure that the bandwidth that is consumed in the most efficient means possible. In short, we do believe that the AT&T network strategy with the complementary technologies is to provide our customers with the best overall mobile broadband experience, both today and in the years to come. And with that, I'll take some questions.
All right. Well, great. Thanks, Gordon, for a great presentation. Don't know if anybody has any questions. We do have some time for some questions. But also, Gordon's going to be on a panel this afternoon, too, if his voice survives. Hopefully we'll be okay there. Anybody have any questions, perhaps, right now for Gordon? Nothing yet? Well, I'll start off with one myself. I know you kind of mentioned, too, the 700 megahertz spectrum. You guys, I think, recently purchased some more from Qualcomm. Mm-hmm. Can you talk a little bit about how you're kind of integrating all the different spectrum bands for the use for LTE? I mean, you mentioned AWS and 700 megahertz. Maybe talk about I guess any challenges there with doing that. It does seem like the spectrum or the standards bodies are kind of helping out when it comes to using multiple bands. But maybe any sort of challenges you're seeing there with integrating all that.
Yes, that's actually a great question. So initially, when you go and you look at the spectrum itself, whether you talk about the lower 700 or the AWS, the technology and the standards today support that in kind of an overlay type of scenario. So you can use the 700 spectrum to propagate and use the AWS spectrum to really use in small cells and areas to improve coverage and minimize your interference. From a longer-term perspective, when you start thinking about the higher speeds that customers are going to demand, you certainly will have what's known in the industry as carrier aggregation. The standards bodies, 3GPP, has started to do some work in that space. It's going to take some additional work in Release 10 as well as Release 11. But we're working aggressively in the standards with our partners to work out some of the kinks on how can you take all of the different spectrum, have it together in an aggregated way so that you can efficiently utilize the full bandwidth at one time for one user. And so that'll increase efficiencies. It'll also increase throughputs. And so that's how, when you think about the evolution of LTE, that's where it's going to come from.